In this video, we're going to start talking about solving quadratic equations. We have several ways that we're going to solve quadratic equations, four to be exact. We're going to start with the simplest ones and move into more complex ones. We'll start by solving quadratic equations by taking the square root of both sides, and solving quadratic equations by factoring, and later factoring by grouping. Okay? So a ball is launched into an air from a height of 100 feet with a velocity of 48 feet per second. At what time does the ball reach its highest point? How long until the ball hits the ground? Another problem. A farmer has 1,000 feet of fencing. He was to create a rectangular pen for his pigs. The dimensions of the pen will be x feet by 500 minus x feet. What is the area of the largest pen the farmer can make? Next, these problems can both be solved using quadratic equations. The first problem, if you've taken physics, you know that a quadratic equation that looks like this one models that the altitude of the ball over time. And if we could solve that, set it equal to 0, that way it would tell us when it hit the ground. We could also find its maximum height. In the second problem, the area formula, area equals BH, and the dimensions of the pen combine to give area is x times 500 minus x, okay? and actually we could put 1,000 in for A as well, and we could solve that as well. So there are lots of ways quadratic equations are useful, particularly in physics involving projectile motion, okay, and various other applications. So a quadratic equation, or also known as a second degree equation, is of the form ax squared plus bx plus c equals 0. If it can be written in that form, it doesn't have to be in that form all the time, but if it can be written in that form, it's a quadratic equation. A, b, and c are real numbers, and a is not 0, because if a was 0, it would no longer be a quadratic equation. Solving quadratics is particularly useful, and we're going to focus on how we do that. There are 4 different techniques we're going to talk about. These techniques work for some quadratics, and that would be taking the square root, and then factoring. Those only work some of the time, not all of the time. And then all quadratics can be solved if there is a solution using completing the square, which we will get to later, and the quadratic formula. So let's look at solving by completing this, not by completing the square, by taking the square root of both sides. Okay. Now we may have to do some earlier work before we get to taking the square root. In other words, we have to get this x squared by itself first. So in the case of this equation in example 1, we would first have to divide both sides by 5, and we would have x squared equals 81 divided by 5. And we're going to leave it like that. And then we would take the square root of that. And so it would be x equals plus or minus the square root of 81 over 5. And you can figure out what that is in a decimal by yourself. 9 over the square root of 5, or 9 square root of 5 over 5. But for now we can leave our answer like that. So you can see we still have to do a little bit of arithmetic before we can take the square root. Next, another example. So we want to solve this equation. Now you notice last time we took the square root, it was the last step. When we solved this equation here in example 1, taking the square root was the last step. That's not always going to be the case. Sometimes we have to take the square root in the middle. And this is one of those cases. Now we're going to have to take the square root, we're going to have to divide by 2, we're also going to have to add 3. And it's just a matter of when we do those things. First we have to divide by 2. And then that would leave me with x minus 3 squared equals 23. Now I take the square root of both sides, which would give me x minus 3 equals plus or minus the square root of 23. And I had to do that first because I couldn't add 3 to both sides as long as it was inside the parentheses with that squared. Now I can add 3 to both sides and I get x equals 3 plus or minus the square root of 23. And you can leave it in exact form like that. Only if you have a word problem would you be absolutely have to change that. So that is a couple examples of solving while we take the square root of both sides. Let's look at, before we look at solving by factoring, we have to know the zero product property. And it's an important one, and it only applies to 0. No other number has this property. The zero product property says that if two things are multiplied together and they equal 0, so if A times B equals 0, the only way that that can happen is when either A equals 0 or B equals 0. It's the only time that we can have that happen. One of those two things equal to 0. That helps us to solve quadratics that we can factor. Factoring wouldn't do us much good if we did not have this. Okay? So let's look at one right here. Solve x times x minus 5 equals 0. Well, these are two things multiplied together, x and x minus 5 multiplied together, and they equal 0. So one of those two things has to be 0. So either x equals 0 or x minus 5 is equal to 0. Of course, that's just 0. If I add 5 to both sides, I get x equals 5. So those are my two solutions, x equals 0 or x equals 5. So let's talk about how we would solve a quadratic equation by factoring. One's where it's just this x squared. So let's write out a way to do that. First of all, we have to have x squared plus bx plus c. It has to be equal to 0 first. If it's not equal to 0, get it equal to 0. And notice I didn't put the a on the beginning here. I didn't put the a, no a, in front of the x squared there, because we're going to do it a little bit different when the a is in front of the x squared. We're going to use something called factoring by grouping. So when we have it in this form, we look for two numbers that do two things: add to b and multiply to c. And we use those numbers to get our factors. And we're going to factor into x plus a times x plus b equals 0. Something that looks like that. Alright, so let's look at example 4 and let's do this one then. Solve x squared plus 11x equals 26. Well, first thing we have to do is get it equal to 0. So we have to subtract 26 from both sides. So I have x squared plus 11 minus x minus 26 equals 0. Now I'm going to factor. I need two numbers where they add to 11 and they multiply to negative 26. So we look at things that multiply to negative 26, like 1 and 21 and negative 26, negative 26, positive 26 and negative 1, but none of those add up to 11. So obviously 2 goes in, So 2 times 13 is 26. We need it to be negative 26. So one of these two has to be negative. Either the 2 is negative or the 13. Well, we look at what it has to add to. If we make the negative 2, negative 2 plus 13 is positive 11. So now we factor using those two numbers, and we get x minus 2 and x plus 13 equals 0. And now the zero product property, x minus 2 equals 0, or x plus 13 equals 0. So x equals 2 or x equals negative 13. Those are our solutions. Let's do another one. Solve x squared minus 14x plus 40 equals 0. So we're looking for things that multiply to be 40 and add to be negative 14. Well, negative 10 and negative 4 do that. So take that, we get x minus 10 times x minus 4 equals 0. So set those both equal to 0, the zero product property again. And so x equals 10 or x equals 4. Now you have these two down here that you can try. You can certainly pause the video, try those, and then come back and see how they're done. So the solution for A, we would first take this equation and divide both sides by 4. And we get x minus 3 squared equals 4. Now we take the square root of both sides. So that's x minus 3, and the square root of 4 is plus or minus 2. And now add 3, so x equals 3 plus or minus 2. Now in this case I would not leave it like this, because 3 plus 2 and 3 minus 2 are simple math, so I'm going to do that. So x equals 3 plus 2, which is 5, or x equals 3 minus 2, which is 1. Those are our two solutions for A. For B, we look for two things that multiply to be 30, and we always look at multiply first because there are fewer possibilities, fewer things that multiply to be 30 than there are that add to be negative 17. So I'm looking at 30 and 1, 15 and 2. 15 and 2 are going to make 17, but I need negative 15 and negative 2 because it has to make negative 17. So it would be x minus 15, x minus 2 equals 0. And I'm going to skip the zero product property step. I'm not going to write it out. I'm just going to know that this either x minus 15 equals 0, which means x equals 15, or x minus 2 equals 0, which means x equals 2. So those are my two possible solutions for that.